The final talk in the first half of this morning session will be given by Van Husson. The title is Modeling NASA SLR Multi-Photon Receive Energies.
Good morning, everyone. Buenos dias. So my talk's on modeling NASA SLR multi-photon receive energies. So I hope to answer some of these questions during my presentation. First question is, do NASA MOBILES and TLRs receive signal strengths vary by station? Second question, are receive amplitude variations elevation dependent or range dependent? Third question, if we model receive amplitude variations, is there any evidence of LAGEO satellite signatures in our systems? Fourth question is, does modeling receive energy impact the mean LAGEO's range bias? And the last question is, what are the risks to modeling receive amplitude in the NASA SLR network? Okay, this is the plot. Once a month, our systems are supposed to take a discriminator test where they range to a ground target and they try and take data over the whole dynamic range of receive energies. The receive energies are measured by a quad integrator, and it's the area under a curve. In our systems, we employ two cascading discriminators to minimize time lock in our constant fraction discriminators. The CFDs trigger on the centroid of the receive pulse. So these are plots of, up here is a discriminator test for MOBILES 4, where this is plus or minus, so the bin size here is 5 millimeters. 5 millimeters here to here. So all the scales on this axis are the same. This is MOBILES 4, this is Yargadi, MOBILES 5, this is Heart of Estock, MOBILES 6. This is MOBILES 7 in Goddard. This is MOBILES 8 at Tahiti. And this is TLRS 4 in Maui, Hawaii. This is MOBILES 4 receive energies on LAGEOS 2, where I selected 3 LAGEOS 2 passes from 2020 when they were ranging at 5 hertz. So on the top set of plots, so time is on the x-axis on all 6 plots. Receive energy is on the right axis. The orange dots represent single returns. And the black line is a running average of receive energies. And the blue is either on the top set of charts, the blue is satellite range. And on the bottom plots is, on this axis is elevation angle. So as on this particular pass here, you can see as the elevation angle increases, the receive energy also increases. Likewise here, on this particular pass, the receive energies tend to increase with elevation angle. This is almost a 90-degree pass where the receive energies, they oscillate, but they didn't seem to really change much. So what I do in this chart is I aggregated from several passes on these different satellites, Sentinel, Starlet, LAGEOS, and Odyssey, the residuals as a function of receive energy on the left axis. And then on the right axis is the cumulative distribution of receive energies on these different satellites. So back in this time, the LAGEOS and LEO data were taken at 5 and 10 hertz respectively. And greater than 90% of the LAGEOS data, which is the blue and red, so 90% of the data has receive energies that are between 6 and 800. On the right are the 4 satellite retroreflector arrays and a number of retroreflectors. So on Sentinel, you really only have 2 rows of retroreflectors, 7 retroreflectors in total. Starlet has 60 retroreflectors. Lagios has 426, and Hajisai has 1,436 retroreflectors. So based on this discriminator test, now I tried to, if we go to the last chart, I tried to apply the discriminator test results to the residuals, and here's what I get. So on the left chart is Hajisai. So peak to peak here is 20, the x-axis goes from minus 10 millimeters to plus 15 millimeters. So the scale on all 3 charts are the same. So here's Hajisai, where we see variations of more than 10 millimeters as a function of receive energy after we remove the discriminator tomahawk curve. On Lagios 1 and Lagios 2, we see a linear drift here of, so here's 5 millimeters here, so a little bit more than 5 millimeters. And then on Sentinel and Starlet, you don't see much variation because those retroreflector arrays are pretty simple. So one question is, are we seeing the Hajisai and Lagios satellite signatures? Are we seeing something else? Or did I really mess up when I tried to remove the discriminator curve? When I applied on Lagios, when I applied the discriminator curve to both Lagios 1 and Lagios 2 in the calibration data, the mean range bias changed at less than 1 millimeter. So there are some barriers to modeling receive energy, though. Let's see, on this chart here, this is Monument Peak here's 3 consecutive discriminator tests over 3 consecutive months. This is November 2011, 2021, October 2021, September 2021. And these curves look fairly consistent. Here's Greenbelt over 2 consecutive months. And here's Tahiti, where this looks, something weird looks here on this discriminator test. And then here's Monument Peak a couple years later, or 1 year later, or maybe 6 months later, where this is 6 months earlier, where it looks like the trend has changed a little bit. And here's Goddard in a different time period where the trends definitely changed. And then here's Tahiti, where the trends definitely changed from here. So these discriminator curves change over time. Here's a residual plot of Mobile 7 at Greenbelt residuals. So on the left axis, we have receive energy from 0 to 1200. The blue is when the system was ranging at 5 hertz. The orange is when the system was ranging at 10 hertz. And here on the right axis in the green curve is the range to the satellite. The time gaps are when they switch to another target. So when they switch between 5 and 10 hertz, for some reason the receive energies, which is the area under curve, is quite different between 10 hertz and 5 hertz, which we still don't understand why this exists. There's about 100 unit difference between 5 and 10 hertz when we range the Lagios. You also notice that when we increase 90 degrees of elevation, which is the receive energy drop off because the mount can't keep up. So here's my original questions and their answers. So the signal strengths do vary by station. The receive amplitude variations, elevation or range dependent. Sometimes they are, but they're path dependent. If we model receive energy variations, is there any evidence of Lagios signals or Lagios satellite signatures? I think the answer, unless I did something wrong, is the answer is yes. Does modeling receive energy impact the mean Lagios range bias? So I only looked at Mobus 4 and Yebes 4, there didn't seem to be much change in range bias, but it's inconclusive. I need to do this analysis in other stations. And then what are the risks to implementing modeling receive energy amplitude? The measurement is sometimes unreliable or unavailable, and the time-out characteristics for a given station can change over time. And the receive energy differences between 5 and 10 hertz Lazius range are still not well understood. Thank you.
Thank you, Van. Any questions to Van?
Tom.
Tom.
When you change from 5 to 10 hertz, by the flip of a switch, possibly there can be change in pulse width.
Well, the beam divergence does change.
Beam divergence can change. So there are a number of factors affecting the transition from 5 to 10 because you're not really optimizing to each configuration as you're making the switch. So that's one thing. Now, the general comment that I have is discriminator has no linear characteristics outside the dynamic range. So it doesn't really matter which satellite you're arranging. Ideally, you want to map for the instrument response, which is really a discriminator here. So you can actually map the nonlinearity of the discriminators to linearize the problem of these range measurements. So that can be done. Now, of course, part of the problem is it's also pulse width dependent. And when you range to targets, the pulse width broadens. So those issues are there. But, and most of the problems that I'm seeing is on the high energy side, high amplitude side, where there's much more steeper nonlinearity as opposed to in the closer to the threshold, which is really cut off by the discriminator anyway.
So I'm not sure there's a question there that he asked.
I was just making a comment.
On a ground target, we don't see much difference in receive amplitude off a single cube between 5 and 10 hertz. We've done some testing between 5 and 10 hertz, where you can see the transmit power changes, but the receive amplitude doesn't seem to change too much. The minimum values don't seem to change off a single cube, but on Lazios, there's a definite trend between 5 and 10 hertz in the receive energy.
Thank you.
Thank you.
Thank you very much.